Good morning, class of 2026. This is Mr. Hunt coming back at you. I want to say live, but it's not live, it's recorded. All right. Coming at you today, we're going to continue in the same vein that we were in. We were talking about calculating the surface area of pyramids. Remember, a pyramid has one base. So we're looking at the area, the surface area, which means by definition is a combination of the areas of all the surfaces. So these are pyramids. Now, you know that they're pyramids because they have one base, but also what type of pyramid it is defined by the shape of the base. The base will be the bottom or the top. Remember, in our terminology, we learned that base is bottom of top. So looking at this, the bottom of this shape has a shape of a what? Triangle. So this is a triangular pyramid, okay? Triangular pyramid. So that means it has three sides and it has three faces. Now, so what are the shapes that are in the net? Number two, what are the shapes that are in the net? Looking at this net, there are four triangles. Look at this net right here. Let me scroll up some. It says number two, what are the shapes that are in the net? The net has four triangles. See them? One, two, three, four. The center triangle is the base right here. Imagine that you unfolded this thing and then laid it flat. You unfolded this pyramid and you laid it flat. This is your base. Now notice all of these triangles have the same dimensions. What I mean by that is they are, first of all, equilateral triangles. That means all the sides are the same length. If the sides are the same length, then a height has to be the same length. So here is the base of your triangle. All four triangles are the same, and here is the height of your triangle. Remember, area of a triangle is 1/2 base times height, okay? So my base is 24, my height is 16. I'm doing 1/2 base times height. But I have four triangles. So I'm calculating the area of one triangle and calculating the area of the other three, and I'm combining them all together. But since they are all the same, they all have the same dimensions, then I will put 1/2 1/2 times 24 times 16. 1/2 base times height. Now, and then multiply that by 4. Here we go. Scrolling down, it says find the total surface area of the three-dimensional figure. The figure has equilateral triangles. They all have the same base. They all have the same height. So I'm putting here in my formula right here the area of a triangle. Area of a triangle is 1/2 base times height. Bam, put it right there. It's in there. The base is 24. The height is 16. 1/2 times 24 times 16. 24 times 16 is 384. And 384 times 1/2 is 384/2, which is basically a division problem. 384 divided by 2 is basically 192. So the area of one triangle is 192 inches squared. Remember, the units are squared. So now, because we have 192 inches squared, one triangle is 192 inches squared. Well, what about the other three? Well, they're all the same. They all have the same area. So just put a 4 in front of this and multiply it by the area of the first triangle that you calculated. So 4 times 192 is 768 inches squared. So the area of this type of triangle, which has the same, which all four triangles are the same, is just 4. The formula mean for this triangle, for calculating the surface area for this triangle, is find the area of one and multiply it by 4. That's how you do it. When you have equilateral triangles, this particular type of pyramid, triangular pyramid, has equilateral triangles. You may not always see that. On the second problem, you're about to see a problem that does not have equilateral triangles throughout the whole shape, okay? It does not have equilateral triangles throughout the whole shape. So here we go. Let's look at another one. This one is pretty easy because I know the area. If I know the area of one triangle, then I know the area of all four because they all have the same dimensions. Let's look at another one, which is not so simple. So looking at this one, what is this shape? Well, okay, I answer number one. What is this shape? Well, it looks like this is a triangle right here as well, okay? As you can see, I don't know what's going on with me and this software, but let's try it again. Go right here, bam, bam, and bam. Now, notice they're giving you that 10 right there. That's your base. And this line right here is pointing to something going straight up the center of the bottom of your triangle. So the base is 10 and the height is 8.7. So the bottom triangle has a base of 10 and a height of 8.7. Okay. Now that's the bottom or the base triangle. So one triangle has a base. First of all, what are the shapes that are in the triangle? Well, basically there are 4 triangles. 3 of them are the same. One is different. The base of this triangle, the bottom has a base of 10. The base triangle or the bottom triangle has a base of 10 and a height of 8.7. The other 3 triangles are slightly different. Let's erase some things here so we can see and go right here, and I'm going to try to draw again. Here we go. So this is 10. This is an equilateral triangle. This has to be 10. If that's 10, then this has to be 10 too. So it's 10 all around, okay? But here you go. This is your height of your triangle. The 3 triangles around the face, around the sides of this, the height is 14. The base of them are 10. So you have 3 triangles, 2 in the front, 1 back here that you can't see. They all have a base of 10 and a height of 14. So 3 triangles have the same dimensions. Base equals 10, height equals 8 points. No, this is wrong. I'm sorry. Let me fix this real fast. This should be 3 triangles have a base of 10 and a height of 14. Okay. Now, 1 triangle has a base of 10 and a height of 8.7. So I messed up on that. Okay. 8.7. I hope I didn't make that mistake further down. So 3 triangles have a base of 10 and a height of 14. 1 triangle, which is the bottom triangle that sits on top of this pyramid, which is underneath this pyramid, has a base of 10 but a height of 8.7. So let's look at this. Here we go. Now look at this drawing. This is the net drawing. Notice that you do not have 4 triangles that are all the same. You have this triangle, which has all equilateral triangle, which all the sides are 10. But these 3 triangles are not. These are called isosceles triangles because 2 sides are equal in length, the left side and the right side. So all of these triangles right here have a height of 14, height of 14, height of 14, height of 14. But the base is 10, the base is 10, the base is 10 right here, okay? So 3 triangles. The 3 triangles are 1/2 times the base of 10 times the height of 14. 1/2 times 10 times 14, okay? That's the 3 triangles. That's the area for one of the 3 triangles. Now, what about this triangle in the center here? Well, the base of it is 10, but the height of it is 8.7. So let's see what we got here. Going down, this is the net drawing. It's like opening it up like that starfish and laying it flat, okay? It's like laying a starfish flat. Here we go now. So the area of the base triangle is bam. Base of 10, height of 8.7. So 10 times 8.7 is 87. 87 times 1/2 is 87 over 2. 87 over 2 divided by 2 is 43.5. So the area of the bottom triangle is 43.5, okay? Now, the area of the sides, the side faces, is the base of 10 times the height of 14. 1/2 times 10 times 14, okay? So 10 times 14 is 140. 140 times 1/2 is 140 divided by 2. 140 divided by 2 is 70. So I have 3 triangles that have an area of 70 each, 70 inches squared each. Units are squared with area. But I also have 1 triangle that has area of 43.5. Okay, so here we go. Total surface area is the area of all the surfaces. So I'm going to add up the area of the base triangle, the bottom, with 3 faces, okay? Well, one of the faces was 70. So it would be 3 times 70. The bottom triangle was 43.5. So 43.5 plus 3 times the 70, okay? That is 210 plus 43.5. You wind up with 253.5. It should be meters squared, not inches. This should be meters squared too. I made a typo. I apologize for that. Okay. So we have 235.5 meters squared. Now let's go back through this. This type of triangle is not an equilateral triangle. Is not an equilateral triangle. This type of triangle, The base is equilateral, but the ones on the side faces was not equilateral. They are not all the same. Okay. All I gave you in the previous problem, which we can scroll up and look at, I gave you this type right here. This type. And if you unfold this, this is what it looks like. If you unfold this type of shape here. But when you unfold this, it looks slightly different. Okay. All right. Now, so you have your assignments today. I will give you the net drawings if you have to calculate an area, or you have to calculate in this type of homework here. If you have to calculate a shape, a triangular pyramid that has a different shaped bottom than it does from the side faces, then I will give you the net drawing as well. Okay. If I do not give you the net drawing, then you basically be calculating it this way right here, where all four triangles are the same. Okay. That will be 4 times 1/2 times base times height. Okay. There you go. I hope you guys enjoy this assignment. And I will be reading out some of your comments tomorrow that you made in the Google Classroom. All right. Love you guys and miss you. Have a good one. All right. Bye.